Today we're going to talk about stating the domain of functions without having a picture in front of us, and then also talking about the combination of functions. So there's a few times where we have to state the domain without the picture, and our main concern is domain restrictions, so we know when to restrict a value. So there's only a few times where I'm not allowed to input certain values, and that's going to happen on two occasions, when I have a fraction or I have a square root. So if I have a fraction, such as 1 over x, the restriction would be that x cannot be equal to 0. So recall from last year that we can never divide by 0. Even when we did graphing in the trig function, we talked about how you can never divide by 0. So if there is a fraction, whatever's in the denominator cannot equal 0. The other time we have restrictions is when there are square roots. And if you recall last year, we talked about taking the square roots of negative numbers and how they yield imaginary numbers. So when you're stating the domain, you're trying to tell me what values would give me actual real y value answers. So if I had the square root of x, whatever underneath the square root must be greater than or equal to 0. So if I don't have a fraction and I don't have a square root, I don't have any domain restrictions. So for our first example, and the directions for all three problems that we're about to do are going to say state the domain. And again, we're doing this without looking at a picture. Recall that domain means your input. So if my function is f of x equals x squared minus 7x. So if you can kind of visualize, it's a squared, so that means this is a parabola. When I look at this function, any number in the whole free world that you picked, you could plug it into this. You could square it, and then you could multiply by 7 and subtract it. So there is no value that I need to restrict, which means every value can be used, which means my domain is negative infinity to infinity. There is no x value that I can't use, so that means my domain would be that. So that's an example of an easy one. So here in our next one, we're going to have a little bit more work to do. So our function is f of x equals 3x plus 2 divided by x squared minus 2x minus 3. So for a problem like this, I can't use every x value in the whole free world because I have a fraction. So whenever I have a fraction, I need to determine what values would give me 0 down here because I can't have that happening. So I'm going to set x squared minus 2x minus 3 equal to 0. And in order to solve a problem to this effect, I need to factor. So I would multiply a times c. And a times c is negative 3. And the combination that multiplies to be negative 3 and adds to be negative 2 is a negative 3 and a 1. So for those of you who did the grouping method, you would say x squared minus 3x plus x minus 3. For my boxers, you would set it up, and you would put x squared minus 3x plus a positive x there, and a negative 3 here. And regardless of which method you did, if I group them, I would take out an x, and I'd be left with an x minus 3. Here I'd take out a 1, and I'd be left with an x minus 3. So I'd get x plus 1, x minus 3. For my boxers, I could take an x up here, an x over there, and negative 3 and a 1. So again, you get the same factorization. And the whole purpose of factoring is to obtain our answers. So when I set both of these binomials equal to 0, I get the answers negative 1 and a positive 3. So I can use every value in the whole free world except these two values, because if I plugged 3 into this equation, or I plugged in negative 1 into this equation, both of those values would yield a result of 0 in the denominator, which would mean I'm taking a number and dividing it by 0, and we know we can't do that because that equals undefined. And your domain is you're supposed to be telling me what values I can use, that would give me a real result. So if -1 and 3 are restricted, our domain is everything except those two values. So I would say -infinity to -1, union -1 to 3, union 3 to infinity. And again, if we were to look at a graph of this picture, that's where you would see open dots. So you would see an asymptote happening at those values. So again, we have to restrict those. So one more example on domain restrictions. So this function is f of x equals the square root of 3x plus 12. So again, now we're talking about a square root, so I can't use every value, because if I use certain negative values when I plug them in, for instance, I would get a negative result. I would get negative underneath the square root, which is an imaginary answer. So I'm going to pull out what's underneath right here, and I'm going to say it has to be greater than or equal to 0. So if I solve this, I get 3x is greater than -12, divide by 3. X has to be greater than or equal to -4. So to kind of prove this to you, if you plug -4 back in, I would get the square root of 0, and the square root of 0 is 0, so I can do that. If I plugged in, so this is if I plugged in -4. If I plugged in a -3, I would get -9 plus 12, which is the square root of 3, and the square root of 3 is a positive number, so I can do that. But if I plug in the square -5, I'll get -15 plus 12, which is the square root of -3, which becomes I root 3. So notice there's this cutoff, and -4 is that cutoff. That's the lowest value I can use. So to write this in terms of our domain, there is going to be no union because -4 is the smallest value I can use, period. I'm not excluding -4, it's just from -4 and up. So -4 is included, and it's only values that are greater than -4 that I can use for my domain. So we're going to pause with that for today. We're going to practice more on seeing the domain restriction without a graph.